You might have heard about the recent feature with the Task Manager in the latest Windows 11 update. I'm updating this hotfix. Hotfix. After the update is complete, I will perform manual reverse engineering analysis. Let's look at the symptoms. After closing the Task Manager window, the process continues to run in the background. You can see there are 3 processes here, but we did indeed close the window. From the perspective of Windows API, closing an application first involves closing the window, then sending messages, and finally releasing resources. Therefore, we can analyze with these APIs. PostQuitMessage indicates to the system that a thread has made a request to terminate. It is typically used in response to a WM destroy message. DestroyWindow is used to destroy the specified window. This function is used synchronous message. And we have exit related APIs. And in message loop, it will use the GetMessageW. This function retrieves a message from the calling thread's message queue. First, we'll use a simple application to understand the program exit mechanism, including which APIs are called, Windows destruction, memory release, and so on. Here we go. So first we attach this process and set breakpoint in this function. You can in memory view and Ctrl G, paste it and search. You can also use this view and reference functions. Wait later and right click, filter or find. That can be work too. So F5 to set a breakpoint. Destroy window. Set breakpoint to. And exit process. Ctrl G, search and F5 to set breakpoint. Okay. So if I click this, you can see the window is closed, but it still exists, definitely. Hello world. Dot hello world. Yes, it exists. So first we post at PostQuitMessage function. I5 to cancel this breakpoint and I4 to run till. And then we got destroy window. So I5, I4, I4 2. Okay. Now let's see this process. Hmm. It's still alive, right? And then I5 to cancel breakpoint and I4 to run till. Since this kernel 32 fatal execute, the process will be killed. You can see. So the task manager should exit processes in a similar manner. How should we proceed with the analysis? My approach is as follows. Object 1. Confirm whether the message loop continues to run after the window is destroyed. We set a breakpoint to get GetMessageW, then close. If still hitting the loop, that main thread has not exited. If exiting the loop, that means should execute the exit process. Object 2. Verify whether exit process is called. If breakpoint hit, process should terminate immediately. If not hit, confirm message loop read. Here we go. Attach this process and memory view. Okay. Function. And I5 to set breakpoint. I5 get message W F5 2. You can see. If I press F5, the process is paused. Okay, F5 cancel and run. This means the program continuously attempts to retrieve message from the message queue, right? And then I click this and it's paused. So I4, 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 I4. Okay. So the task manager first invoke this API and then invoke this API. We pause at this, but the window is destroyed, but the process exists. We can see this. And I5, I4 to post quit message. Let's check this function is work. Search again. No, it's not work. It's not work. We go to message GetMessageW because we can use this function to post process before. So if I press I5 now, the process is not post. That means this function not executed. So the object one is checked, and then kill them, and let's launch another one. So attach this. F5 and click the exit. This function is not work. Not if not hit, that confirm message loop freeze. Okay. And next, the objective 3 is analyze blocking threads. Through memory view to view threads and check the EIP or RIP of each thread one by one. If stuck at wait for a single object or wait for multiple objects, that means synchronization blockage. If stuck at this, that means performance monitoring thread not exit. Right? Let's see. Thread list. Refresh. 2584. So EIP, RIP, Control C, and go to it's ZW wait for alert by thread ID. And A5C RIP and go to it's ZW wait for work via worker factory, and then it's same. It's same. Is user message wait for multiple objects EX. delay execution, delay execution, wait for worker via worker factory, wait for multiple objects, wait for work via worker factory, wait for multiple objects, um, work factory. Let's see. Delay execution. Oh, I forgot where is this? A worker factory. Factory 2. Factory 3. Factory 4. You want to pentakill? I don't know. Um, the last one. Okay, pentakill. Our conclusion is the exit path is blocked at waiting for background works or thread pool tasks or synchronization objects to complete. The main window has been destroyed, but the main thread is waiting, causing the process to remain resident. Since Windows is not open source, we have identified some of the most likely reasons. One, its message loop did not receive WM quit because PostQuitMessage API not triggered. Two, background performance monitoring thread failed to exit. Three, newly introduced APIs such as Copilot or Recall monitoring interfaces, blocking the main thread's destruction path. Other examples that Windows 11 24H2's Task Manager has been partially migrated to a WinUI 3 plus UWP hybrid model, or closing the window only destroys the XAML host, while the main process remains to wait for app lifecycle completion. KB 5067035 may have introduced new asynchronous cleanup logic that forced to release the UI dispatcher. The last is causes the main thread to wait for finished async operation before exiting. That's all for now. Please subscribe and thanks for watching.